In section 3.3, we're going to be writing down some postulates and theorems that have to do with parallel lines. Our goal for the section is to prove results using parallel lines. Remember that postulates are things that we accept without proof, so these are always true. We're going to start with postulate 15. If two parallel lines are cut by a transversal, then the corresponding angles are congruent. So I'm going to draw two parallel lines. And remember that we may know these are parallel if we're given the arrows on the lines. Then they're being cut by a transversal. Our transversal is our line that crosses both. Because the lines are parallel and being cut by a transversal, then our corresponding angles are congruent. So for example, this angle and this angle are congruent. Remember, corresponding are the ones that sit in the same spot. Based on postulate 15, we're also going to have some theorems. Theorem 3.4 says if two parallel lines are cut by a transversal, then alternate interior angles are congruent. So again, we start with two parallel lines. And they're being cut by a transversal. The alternate interior angles, alternate meaning they're on different sides of the transversal, interior between our parallel lines, are going to be congruent. So we have this one and this one. We have this angle and this angle. Theorem 3.6 states if two parallel lines are cut by a transversal, then my alternate exterior angles are also congruent. So we have our two parallel lines. Here's our transversal. Alternate exterior angles are in different sides of the transversal and outside the parallel line. So this angle and this angle, and I know they're the same single arc. Or this angle in the top right, double arcs, is the same as this angle on the bottom left, double arcs. Remember that once we use single arcs to show pairs of congruent angles, then we'll switch to double. We did skip over theorem 3.5 because it works just a little bit differently, so we'll look at that one. Theorem 3.5 says if two parallel lines are cut by a transversal, then the same side interior, or I could call those consecutive interior angles, are supplementary. So if I have two parallel lines being cut by a transversal, there's my arrows to show they're parallel, then I know that same side are consecutive interior angles. This one and this one are not congruent, but they are supplementary. They add up to equal 180 degrees. So the two in a row between the parallel lines add up to 180 degrees. Theorem 3.7 says if a transversal is perpendicular to one of two parallel lines, then it is perpendicular to the other line. So I'm going to start with two parallel lines up in the top right corner of your screen. My two parallel lines. If my transversal is perpendicular to one of those lines, one of the lines at 90 degrees, because they're parallel, it must cross the second line also at 90 degrees. Let's try filling in some pictures of angle measures. We are given at the bottom of the sheet that A is parallel to B. So I'm going to draw the arrows. A is parallel to B. What I know is from postulate 15, I know my corresponding angles are congruent. So this 125 is congruent with this 125 that I'm writing it below. I still have the vertical angles are congruent, so I can fill in the 125 vertical to these. And then from 3.5, I know that the consecutive interior or same side interior angle has to be 180 minus 1. Its vertical angle is 5. Its corresponding angle is 5. And then corresponding to this consecutive vertical to this angle is another 5 degrees. There's a pattern of Let's try a picture that's more complex. I know that A is parallel to B, so I'm going to put center in front of A and B. This is going to have a second set of parallel lines. C is parallel to B. And we're going to fill in our missing angle. Again, I can do the vertical angle to 83. I can also look at a linear pair. My pair of angles that make 180, I have this line that makes 180. So 180 minus 83 vertical to that is another 97. Now, if we could just cover up line D, let's just pretend line D is there for a moment. So now we have A is parallel to B and C is our transversal. The 97 in the top left corner corresponds the top left corner bottom B. The same thing happens with the rest of the group. 83 corresponds above the line and right of the transversal. The 97 is below the line and right of the transversal. 97 below line A left of the transversal is 83. Below line B left. Now let's go back and look at line D. Line D is parallel to C. I'm going to use A as my transversal. So above transversal A, left of line C is 97. Corresponding to that, above transversal A, left of line B is 97. And the other corresponding angles we can fill in. I could also use A and B being parallel and B being the transversal. 83 is an alternate interior or corresponding from the top right. 97 is an alternate interior corresponding with the top left. And then I can fill in my vertical. 97 is vertical to this angle, 83 is vertical. So we get this repeating pattern. In class, we'll be working on book page 146 to 149, problem numbers 8 through 26, and 33 to 44. We'll do part B of 33 in class.